right, so 4-4 has a lot of similar things that we've talked about, right? So we're going to look at trigonometric functions of any angle, not just 30, 45, 60, 90, 180, 270, 360, right? Not just the ones that we know. So how do we deal with it if we, if it's like 95 degrees? So for this first part, let's go ahead and put up here in this, I want you to put a point right here, and then connect from the origin to that point a ray. So this is our initial site, isn't it? So from here to here, the green being our terminal site, isn't this our theta? I don't know what the theta is, but this ordered pair here, wouldn't this be x comma y? Agreed? Couldn't I then, if I gave you some ordered pair, you'd plot it in the coordinate grid, and couldn't I create a special right triangle by dropping it straight down or up, depending upon what quadrant we're in, to the x-axis? You will always draw a vertical line down or up, because it'd be up if I were in the third or fourth quadrants, to the x-axis, and you create this right triangle. So we're going to use what's called a reference angle over here. Or, wouldn't this value here be my y in my ordered pair? And wouldn't this side value be my x of my ordered pair? Right? Couldn't I use Pythagoras' theorem to figure out this distance here, which we'll call our radius, r?
How do you know that it's y?
Doesn't matter.
Say that again, how do I know?
How do you know that y is there?
Because isn't y your vertical distance and isn't x your horizontal distance? Does that make sense? Why? Question?
Doesn't matter.
Doesn't matter what? Which of these is where? Technically no, but yes, it matters for sine, cosine, tangent, right? It matters which is which.
Yeah.
So right over here, isn't r equal to the square root of x squared plus y squared? Isn't that the distance formula? Yes. Or Pythagoras theorem, sorry. Yes.
What do you refer to as r?
The radius from here to here. This is the hypotenuse of the right triangle. Does that make sense? Okay. Any other questions before I go on? All right, so what would be the sum? Now, technically, we're going to use this reference angle here. Well, what color am I putting? I'll put it in blue. So I'm going to use this reference angle here. We'll be able to use that reference angle because both this theta and this reference angle right here, don't they have that point in common? Right? So I can use this reference angle, whatever it might be, and oftentimes it'll be one of the ones that we know, 30, 60, 45, that kind of thing, to find my sine, cosine, tangent. So for sine, it's what over what? Opposite over hypotenuse. So what's the opposite to this little angle here? Y over, so this becomes y over r. What's the cosine? What over what?
X over r.
Adjacent over hypotenuse, which is x over r. And what's tangent? Opposite over adjacent, which is y over x. And so aren't these the inverses of these? So we have r over y, r over x, and x over y. Now, having said that, x, y, and r, obviously r is not going to be 0, cannot equal 0, correct? R is not going to equal 0, though. It would be impossible to have a right triangle. So we're going to use that knowledge, and then there's going to be some restrictions. So do you remember this? So I pointed out wee long ago. wee long ago. All students take calculus. All students take calculus, right? That means that all sine, cosine, and tangent are positive in the first quadrant. Only sine is positive in the second quadrant. Only tangent is positive in the third quadrant, and only cosine is positive. That means that all others in these quadrants are negative. Because if you look at, let's just look at this right here with this one. So if I'm in quadrant 2, what is positive in quadrant 2? Sine. Notice that this would be the only positive one. Y, isn't it going in a positive direction? Right? Because y is positive. And wouldn't x be a negative, technically valued? So for sine, I'd have y over r. So I'd have a positive over, the hypotenuse is always going to be positive. Is somebody trying to get in the door? Is that just me being crazy?
Yes.
Okay, okay, I am crazy, I know. My family would tell you so. All right, so since x is negative, for cosine, wouldn't this be a negative over a positive? So this one would be negative. And then tangent would be a positive over a negative. So this would be negative. And when you flip it, wouldn't this be negative and this be negative? So these are actually both positive, but that's because cosecant is the inverse of sine. But if we worry about these, then these fall into place, don't they? And so in here, isn't our x and our y negative in this quadrant 3? Both x and y are negative. So if x is negative and y is negative, this is going to be negative, this is going to be negative, but what's going to happen here? Negative over a negative will be a positive, so that's why tangent is the only one that's positive. And over here, cosine, I've got a positive x but a negative y. So positive x but a negative y, that makes this negative, makes this positive, makes this negative. Yes. In here, y is negative. In the fourth quadrant, y is negative, right?
Yeah.
And x is positive. For all ordered pairs, right? Does that make sense? Okay. So bearing all that in mind, you have to pay attention now to signs. We haven't had to do that before. So let's look at some examples. And here, by the way, sine is restricted on the unit circle. Sine is restricted to, and we're going to see the graphs of sine and cosine and tangent later, but you'll find that on the unit circle, sine is restricted from 1 to -1. Whereas cosine is restricted from -1 to 1. Cosine is restricted this way. Sine is restricted this way. And you'll see why, because look what happens. Well, we'll talk about why those restrictions are there when we get to an example that'll make sense. All right, so look at number 1. Let -4, 3 be a point on the terminal side of theta. Find sine, cosine, and tangent. So the very first thing I'm going to do is draw and estimate where that ordered pair is. So I'm going to draw my xy coordinates. And then I'm going to plot about where that point would be. What quadrant would -3, 4 be in? The second quadrant, right? So I go to the left 3 and up 4. So there's the point, give or take, -3, 4. So I'm going to connect that to my origin. And then from here to here is my theta. This is the terminal side of theta. But I'm going to draw my reference triangle in the coordinate grid. So I'm going to drop down to the x-axis and create this right triangle. If my x value is -3 and my y value is 4, what is this distance from here to here? Is this x or y? This is y. So isn't this value here 4? Isn't this value x here? Because x is negative, doesn't it make sense that this is -3? Okay? So for me to find sine, cosine, and tangent, don't I need to know my hypotenuse? All right, so I'm going to then, step 1, I'm going to use r equals the square root of x squared plus y squared. That comes from Pythagoras' theorem, right? So plug that in. So I'm going to square 4 and oops, I put them backwards now. -3, doesn't really matter, does it? And 4. So I get 9 plus 16, square root of that, square root of 25 is what? 5. So r is equal to 5. Does that? For what?
For
Inside?
Make sure from
Oh, that doesn't matter because we will never have a negative R. R will always be a positive value. Even though technically distance isn't negative, right? In the coordinate grid it is for these purposes. All right, so R is fine. So then we have to find sine of theta, cosine of theta, and tangent of theta. So this is step 2. Yes.
What if the triangle was like in quadrant 3?
Well, we haven't gotten there yet. If it's in quadrant 3, then you have negatives, right?
Like,
So if
yeah.
you had -3, -4, your point would be down here, right? You draw your hypotenuse here, and wouldn't you go up, your vertical line to go up?
Yeah.
So you'd create your triangle upside down.
And would the hypotenuse be negative?
No, hypotenuse will still be positive, because if you square 2 negatives, don't you get a
Yeah,
positive?
yeah,
Does that make sense?
Yeah.
All right, so then I get, even though this says theta, it doesn't matter whether I'm using this angle or this angle, they both have the same terminal side, right? So I'm still using this angle right here. So sine of this reference angle is opposite 4 over the hypotenuse of 5. So there's my sine. My cos, yes.
Right, near the second quadrant, you always use that angle.
I will always use the reference angle that is in the triangle, not outside the triangle. And then for my cosine, wouldn't it be -3 over 4? And what's your tangent? Oh, I just did that. Oopsie poopsies. 5. That's what I get for thinking. Thanks, Kelsey. You made a mistake, but you can chalk that up as 1. So what's your tangent? Oh, we'll each take a hit. I'm just kidding. All right, what's my tangent? 4 over -3. That's all they asked for, so I'm not going to do their inverses. Does that make sense how we got those? Okay, I still don't know what theta is, but I do know what the sine, cosine, tangent is. All right, so look at B. Look at, see, how is B different? Well, they gave you 2 things. First of all, because now you're seeing some restriction going on here. They haven't given me an ordered pair, right? They've given me tangent, which is negative, and they've given me that cosine is what? No, cosine is positive. Greater than 0, right? So let's draw our coordinate axes. And let's talk about the parameters that they've given us. And I'm going to put x's on here. Where would tangent be negative? All students take calculus. I like to think of where's tangent positive first. Where's tangent positive? First and third, right? Because it's first and third, isn't it? So doesn't that mean that tangent is negative in third and fourth? So I'm going to put an x here and an x here for where tangent is negative. Then it says cosine is positive. What quadrants is cosine positive in? All students take calculus. So it's here and here. Where do they meet? That's where both parameters are true, right? Because we need them both to be true. So I know that I'm looking in the 4th quadrant. So if my tangent, so here's my first step, my tangent of theta is equal to -5 over 4. Doesn't that mean, isn't tangent y over x? How do I know that? Well, go back to this triangle. Over here, isn't opposite over adjacent your tangent? Isn't opposite always going to be your y? It's always going to be your vertical one. So my vertical is always y over x. And that's important because if I'm in quadrant 4, so I'm going to go ahead and just make, it doesn't really matter where you put it. I'm losing my voice, sorry. I'm going to go ahead and go vertically up, create that reference triangle right here. And for your notes, if I were you, I would probably add up here that tangent was in quadrants 2 and 4, and cosine was in quadrants 1 and 4. And so this is what they had in common, quadrant 4. Otherwise you might forget what the x's are for. Yes?
Just a minute ago you said that the vertical, that y is always the vertical.
Correct. Yes, that's correct.
I'm just wondering why can't it be vertical, or horizontal, excuse me?
Why can't y be horizontal? In the coordinate grid, my x is always going to be here or here or here or here. My theta is going to be here, here, or here, right? It's always going to be next to that origin. Won't opposite always be to the vertical side?
Oh, so it can't ever be next to the y?
No.
Or the y? So it's...
Yeah, this will never be theta down here.
Yeah.
It will never be down here. Your theta will always be the angle closest to the origin.
Yeah, okay, I was thinking that it could be on the other side.
Yeah. No. And for this one, I want to look at theta being here. Because remember, even though technically we're all the way over here, that's my reference triangle, that's my reference angle. And so y is 5, but is y positive or negative here? Because one of these two is negative. Is y positive or negative in the fourth quadrant? It's negative because it's below the x-axis, right? So isn't this going to be negative 5? And so this is my x, my adjacent to here would be 4, and that's a positive 4, and it's really important to get your signs correct, because otherwise you'll mess up your answers. So then, what do I need to find? My radius. So I'm going to use radius is equal to the square root of x squared plus y squared. So you go ahead and find that. And some of these you might recognize and wouldn't have to go through all of this. Is this a 3, 4, 5 triangle? No, why?
Because the hypotenuse has to be 3.
Right, hypotenuse can't be 3 here, correct?
Yes, for the extra quiz to show what for articles.
It depends. I'd like to see what you're plugging into the calculator. But you could plug this into your calculator and spit out the answer. But the problem is the answer they're going to give you in the calculator is a decimal. And I don't want that. I want the simplified radical.
Well, if you already know it, it's like the square root of that.
Yeah. As long as you show me what you put into it to get there. Because that way if you get it wrong, I can at least give you some credit for putting it in correctly. So what's 16 plus 25? 41. So it's not a nice happy radical, correct? So over here I'm going to put the square root of 41. Then you need to find sine and secant. Is secant the inverse of sine? No. So I'm going to find sine of theta. I'm going to find cosine of theta. Why? They didn't ask for it. I needed to find secant. It's easier to find secant that way. And so then I can find secant of theta. So sine is what? Negative 5, right? Negative 5 over square root of 41. Can we have that? No. So multiply top and bottom by square root of 41. And what do you get? Negative 5 radical 41 over 41. And 5 does not cancel into 41. So that was lovely and fun. But we did it, right? Your calculator will not give you this answer. Then what is cosine? 4 over the square root of 41. Now this is what I would use. Now I wouldn't even don't give me the rationalized form of this, because do we really need cosine? No, but I would use this form to find my secant, right? I wouldn't even use the rationalized form. So since we don't need this, I'm not asking for it, I would just go ahead and flip it. Square root of 41 over 4. And did your cosine turn out to be positive in the fourth quadrant? All students take calculus, right? So that worked, yes.
Could you explain how you actually figure that out? Like,
Which
how
one?
do you know that, like, tan is negative in those quadrants?
Mostly because, I mean, we could look at, you know, this in each and every quadrant and see the signs. I've given you this as a shortcut, that these are where they're always positive. So all three of them, sine, cosine, tangent, are positive in that quadrant. Here, only sine is positive. We kind of talked about that with this one, right? Why that is. If you went and made a reference triangle here and here, we could talk about it for these ones and these ones too. But here, think about tangent, or just think about here. Isn't x and y negative here? So if x and y are negative, go back and look up here. If x and y are negative, and r is always positive, right? Won't this be negative? Because y is negative. Won't this be negative? Because x is negative. If x and y are both negative, won't that be positive? That's why tangent is positive here. Okay? Do the same thing for the fourth quadrant. This time though, x is positive and y is negative. Right? So if x is positive, y is negative. This is a negative over a positive, so that's negative. But this is a positive over positive. That's why cosine is the one that's positive in this quadrant. This one we have negative over a positive. That makes it negative. That's why. That's how come I know. But the shortcut to having to go through that every time is knowing this. In addition to that, I really don't even have to know that if I pay attention to my signs when I draw my reference triangle, right? Making sure what is the sign of y, what is the sign of x, just by looking at your dimensions in the coordinate grid, right? So either way you want to do it. All right, so flip it. All right, so look at example 2. Find the following trigonometric functions. Well, okay, pi over 2, isn't it one of those north, south, east, west points? Okay, is it north, south, east, or west? North. What is the ordered pair associated with it? Yep, 0, comma 1. And we want to find all 6. I didn't tell you that, but we want to find all 6. So we've got sine of, they didn't give us it, so we'll say theta, cosine, tangent of theta. What is the inverse to sine? Cosecant. So secant, and then cotangent. So remember that this is cosine and this is sine, right? So what is the sine of pi over 2? 1. So just by looking at the ordered pair, right? What's cosine? 0. But tangent is what over what? Yep, or you can think of it as sine over cosine, right? So this time we get 1 over 0. Is that possible? So tangent is undefined at pi over 2. You have to use the words UD, or you have to physically write out undefined. Yes.
I think you take, pi over 2 is 90 degrees, right?
Correct.
So if you take the tangent of 90 degrees.
You're not allowed to use your
Yeah.
calculator though.
Well, I'm saying if you do use your calculator.
It should come out with error.
Yeah, that's it.
Yeah, yeah. But you're going to have a calc portion and non-calc portion, so you need to learn how to do it without the calculator. So that's the only reason I point that out. So then when you flip these, sine is 1 over 1, right? So when you flip it, you still get 1, don't you? But cosine is 0 over 1, isn't it? Put this over 1, isn't it 0 over 1? When you flip it, don't you get 1 over 0? Is that possible? So secant is undefined. But what happens to cotangent when you flip this? You get 0 over 1, which is 0. So for pi over 2, tangent and secant are the only ones that are undefined. Question.
Why is it undefined? It's
Because
actually
can you
zero.
have 0 in a denominator? No. You can have 0 in the numerator of a fraction, but you cannot take something and break it into no groups whatsoever. If I took all of you and broke you into no groups, wouldn't I have one group of 20 or whatever it is that we have in here? It's impossible to take this group and break it into no groups, because you're at least one group, right?
Yeah, but
It's
we
undefined.
actually-
And it's undefined. If you take 1 and divide it by 0, let's just do this above here real quick. 1 divided by 0. 0 times what will give you 1? A lot of people will say 0 or
But it's
1
not
or whatever.
like that.
Doesn't matter what you choose, 0 times anything is 0. Is that what we get under here? Because you're supposed to be able to multiply these two to get here.
So is that why?
That's why.
Probably never.
Because you cannot, because these two are being multiplied together, you can never multiply anything to 0 and get anything but 0 here. So this is what? 1 divided by 0 is this, right? So if you flip it, 0 divided by 1, 0 divided by 1, 1 goes into 0 how many times? 0 times. 1 times 0 is 0. That one works. That's why. Mathematically, that's why. I know, but you need to learn that 0 cannot be in a denominator, right? All right, pi, is that a north, south, east, west direction? Yes. What is its ordered pair? It's west. It is west. So -1, 0. So isn't this cosine and isn't this sine? So write them all out. Sine, cosine, tangent, cosecant, secant, cotangent. So what's sine? 0. Cosine, -1. Tangent is 0 over -1 because it's sine over cosine. Is that possible? Yes. No, I can have 0 in the numerator, right? That is possible. So tangent is 0. Then what's cosecant? Because this is 0 over 1, right? Flip it. You get 1 over 0, which is why this is undefined. So your notes, you do want to put 1 over 0, because otherwise you'll go, why is it undefined? You'll forget. And then what's this one? It's still -1, because this is -1 over 1. 1 over -1 is still -1. What about this one? Flip this one. We have -1 over 0. That one's undefined. So for pi, cosecant and cotangent are the ones that are undefined. Yes.
If you like get -1 over 0 and you don't put undefined.
You will get it wrong, because you have not told me that it's undefined. And that's the most important part, is that you understand that that's undefined.
Just check.
All right, so now we come to reference angles. So we're going to draw these angles in the coordinate grid. Whoops, just lost my straight edge. And let's look at what our reference angle is going to be. Remember, I draw a right triangle to the x-axis, correct? So here I'm going to draw a coordinate grid, x and y axis. Just set them right there. Thank you.
I have a question on this one. Is
Can you
that the
wait?
equation? Is that
No,
supposed
you
to-
went too far. Do it before that, the one before that. All right, so if I'm going to do 150 degrees, what quadrant is 150 degrees in? The second quadrant, right? So let's just say, oh, it's right, right about here. So from here to here is 150 degrees, correct? Would you agree with that? Give or take, but it's in the second quadrant, right? Then my reference triangle, we're going to say, is right down here. Always go straight down to the x-axis. This right here is my reference angle. What angle would that be? Yeah, so theta is equal to 180 degrees minus 150. You always go, it's either going to be 180 here or 360, because it's always either side of the x-axis. So that's how we end up with 30 degrees. That's my reference angle. It's important that you can find that reference angle. So because you might have lost what we were doing here, this is what we're calling reference angles in really big letters. All right, so do the same thing with 300. What quadrant does 300 fall into? Which one? 4. Did I hear 4? Okay, that's what it is, 4. So, it doesn't really matter where you draw it. I tend to just draw it kind of in the middle, only because I don't really care. All I care is that it's in the 4th quadrant. So from here all the way to here that is my 300 degrees, right? But my reference angle, I'm going to go straight up to the x-axis. Thank you. And so this is theta right there. How far is it from here to here? Here's to find theta for this one. The closest on the x-axis is 360 degrees, right? So I would take 360 and subtract 300. And so doesn't theta equal 60 degrees? Don't we know what to do with a 30 degrees or a 60 degrees, right? Those are our special right triangles. So you find 240. You find the reference angle for 240. Figure out what quadrant 240 is in. Draw your coordinate grid. And only go to the x-axis, never the y. This one's a little different though, isn't it? Be smart. How come what? Because we're going to spend several days on this. It'll take you a little while to absorb this. And then we're going to spend several more days on, you know, all next week on the next sections. So that's why. So then look at this. What'd you come up with? This is my picture. All right, so we're at 180, right? But it's 240, isn't it? What'd you do with the 240 and the 180? I can't really do 180 minus 240. What do you get? A negative, and it's not. We don't want to look at it as a negative. So instead, for this one, I should put the 240 first, right? And subtract the 180. Always subtract the smaller. And so what did you get again? You should have gotten the 60 degrees, right? Didn't I hear 30 out there somewhere?
That's because I was subtracting from the 270.
Yeah, that's right.
Oh, see, I said never the y-axis, only the x. Notice that we went up to here. So the closest thing here is the 180 degrees here.
So Miss Mary, it can't be negative.
We don't want it to be negative because we'll pay attention to the signs of our x and y, and that'll make the difference there. All right, so now I'm giving you radians. Okay, so in order to do the radians, we're going to have to do, well, we can count radians because they want the answer in radians. So let's go ahead and count. We're going to count by 6 because that's our denominator, right?
So do you always subtract by 180?
Or, yes, it's either 180 or 360. And it's either 180 minus or something minus 180. Or it's 360 minus or something minus 360. Well, that wouldn't be right. You're going to subtract the 360. Or subtract from the 360.
Would you only do that if it's in the fourth quadrant?
Mm-hmm. Yep. If it's in the first quadrant, it is what it is. Right? If it's in the first quadrant, it's going to be 30, 60, 45. So you're only going to be doing this in the second, third, and fourth quadrants. All right, so remember this is 0 and this is pi, right? This is 0 and this is pi. If I'm counting by 6, don't I have 1, 2, 3, 4, 5, 6, 6 pi makes 1 pi? Won't 7, 6 be over here? So this is 6, 6, and this is 7, 6. So I end up in the third quadrant. The most important thing is that you realize what quadrant do I end up in. I'm gonna end up in quadrant 3. Because this is 7 pi over 6 here. From here to here. Right? That's 7 pi over 6. But this is my reference angle, goes up, either up or down, not right or left, to the x-axis. So, I'm going to take, remember what we did over here? The one right next to it? We're going to put, this is bigger than, this is 6, 6, isn't it? This is 6, 6 pi, right? So I'm going to take for theta, and I'm going to take 7, 6 pi, or 7 pi over 6. And I'm going to subtract 6 pi over 6. What do I get? Pi over 6. Isn't that one of our... Yeah, it's really a 30-degree angle. But they want the answer as... and now if you are more comfortable, could you convert this to its degree measure first? Yeah, absolutely. Convert it to its degree measure first, do all the work, and then convert back. Either way, it doesn't bother me, either way. But, how do I know that this one here is in radians and not degrees? What do you notice about the ones that were given to you in degrees? They all have a little degree symbol. So this one I know is in radians because it's missing that degree symbol. So the first thing I need to do is take 4.78 and I need to convert it. Well, for me, I would convert it to degrees. Just for me, personally. And then we can convert back to radians in the end. Are you stretching?
No.
Okay, yes.
Do you want us to label one radians like that? Average radians?
No. I just, for your note purposes, just know that that's radians. Now, we could do it without radians. And we could do it in radians. Just to let you know. Think about the coordinate axes as radians. Because some of you would prefer, it just depends. This is 0, right? Pi is what in radians? 3.14, right? This is 4.78. So then 3 pi over 2, isn't that what this is? And then I would take, I just get out the handy dandy calculator. Or I would take 3.14 divided by 2. What do you get? 1.57, and then multiply it by 3. And then that's a pain, isn't it? Right? So neither here nor there. Now I'm not going to give you probably this one unless you had a calculator. But if I were to convert, well, let's just go ahead and do that. So take 3 divided by 2. Okay, we're going to multiply that to 3.14. So this right here, and that's where the, remember on here, your unit circle, it has the decimal equivalency somewhere. Oh, it was on that homework page, wasn't it? That worksheet, that handwritten worksheet. So this is where the decimal equivalency comes into place. This is 4.71. This is 3.14. This is, what's half of 3.14 we said? 1.57, and then this is 0, right? Or what's 2 pi? 6.28, right? So it could be either one of those. Now where does 4.78 fall into all this? So we're just barely into the fourth quadrant, right? So we could do it this way. So it's kind of fun. We'll do it this way. Because I find math fun. I know you're all like, what? How does she find that fun? That's impossible. All right, so there's my reference triangle, wouldn't it be? Because from here to here, all the way to here, this is 4.78. Well, we don't need to, because what can we do? To find out what's missing in terms of radians, subtract these two, right? So your theta, which is in here, theta is equal to 6.28, because that's the closest on the x-axis, right? Minus 4.78 equals what? So 6.28 minus, what did I say it was, 4.78? Yep. 1.5, right? And that's in radians, so don't put degrees on that. Now, if we want to convert that to radians, just for chuckle's sake, what would we do? Just to see what the degree is, to see if it makes sense. Multiply it by 180 over pi, right? Because remember, if this is in radians, pi technically is up top, isn't it? And we want to get rid of it. So times 180 equals that, divided by pi. Does that make sense? So that theta would be 85.9 degrees. Didn't we say it was just slightly past here? This would be, going this direction would be 90, right? So it makes sense that that would be 85 degrees, give or take, right?
Oh, and the angle on the left.
Correct.
So
Correct.
you multiply by 180 and then divide by
Correct.
Would that be a calculator function or?
Yeah. Well, we could do it without the calculator though, right? It'd be kind of a pain if you don't have, say I don't have memorized. But still, we'd still have to, the only thing that you had to do is deal with this, right? These decimal radian equivalencies. Yeah, I mean, if you want to. All you'd have to do was go ahead. I mean, I just figure them out. I don't like to memorize a lot, I guess. So it's up to you. If you're a memorizer, go right ahead. I'm not big on memorization. I try to do as little as possible. All right, so look at example 3. This time it says find exact values. Doesn't that usually mean that you're not allowed to use your calculator? Okay. So find exact values for trigonometric functions using your reference angles. So we're just going to kind of do the same thing. So cosine of 4 pi over 3. So we have to find where that could be. What quadrant is that in? Is that over pi or under pi? It's more than what? Over 3, wouldn't that be 3 pi over 3? Right? If the denominator is 3, 3 pi over 3 would be 1 pi, so 4 is over 3. So we're past quadrant 2, aren't we? Because this is pi, right? So this would be 3, and actually I'm going to put here, this is 3 pi over 3, isn't it? Whatever the denominator here is, you're going to put the same thing over the same thing here, so it kind of helps you count. So by the time I go from here to here, I've hit 3 pi over 3. So I would end up in quadrant 3, right? And then draw your reference angle up, correct? So how many more pi's do we have to go past there? 1. So isn't our reference angle is equal to, isn't it really pi over 3? Which is what degrees? 60. Now, you could convert 4 pi over 3 into its degree measure by using 180 over pi, couldn't you? Right? And then figure it out from there, but then you'd have to take that degree and subtract 180 from it, and you'd still get 60 degrees. I don't care how you do it. Abby?
Where'd you get pi over 3?
We want 4 pi over 3, right? So didn't we go 3 pi over 3 to get here, and we had to go 1 more pi over 3 to get to 4 pi over 3. So this, the difference between these two, is equal to that pi over 3. Does that make sense? Okay. So now they want us to find cosine. So all students take calculus. Is cosine going to be positive or negative?
No.
All students take. What's the only thing that's positive in this quadrant? Tangent. So cosine will be negative. So cosine of theta is equal to negative. I will immediately put the negative in there so I don't have to think about it. Then draw your reference triangle. Well, we drew it there, right? So if this is 60 degrees, what's across from 60? No, rad 3, right? This is our 30 degrees. What's across from here? 1, and our hypotenuse is 2. So if this is my reference, right? Cosine is adjacent over hypotenuse. Isn't it negative 1 over 2? Now some of you are memorizing the ordered pairs, right? You're memorizing the ordered pairs of pi over 3, and you would just know, oh, that's -1/2, right? So I might not see all of your work. There's your answer. But I have to say, if the directions say use reference angles, you've got to use your reference angles. All right, so look at B. We'll do this and then we'll finish it up tomorrow. So B, sine of 300, where is that going to end up at? Quadrant 4. So that's easy, right? To look at. What's the reference angle going to be? Yeah, because we got 360 minus 300, right? Bless you. And again. So this is going to be 60 degrees here because from here to here was 300 degrees, so that leaves 60 more. So same thing we did before, across from 60, isn't that radical 3? Here's our 30, across from that is 1, and our hypotenuse is 2. So what is the sign? I guess it's opposite over hypotenuse. Oh, and what's this? All students take calculus. So is sign positive or negative? Negative. And first of all, you could make these positive, negative. This is positive, isn't this one negative? So the radical 3 turns out to be negative. All right, we will do part 2 tomorrow. Your homework is out of your textbook, only a couple problems.